Hello everyone. In this video, I want to introduce you the method which is called U substitution. This is a very useful method for integration. You will use this method or not? Okay, in the future. Um, Now, in the previous study, we have seen that for some functions, we can find its antiderivative by using a power rule. And those functions are very, very simple. Like we know that the integral of x squared dx is x to the third over 3 plus a constant. Why? Because according to the power rule, if we have function like this, then the antiderivative is given by the formula, which is we increase the power by 1, and we divide the whole thing by 1 plus n. Okay. And if a function is a sine or is a cosine, we also can find what is the antiderivative according to the derivative formula. Like the integral of sine x dx, this is cosine. This is negative cosine, and the integral of cosine is sine x. We know this because before integration we started derivative, and when we started derivative, we know that the derivative of sine x equals cosine x, and the derivative of negative cosine x is sine x. So that's why when we see these two integrals, we can immediately know that the answers are negative cosine and sine. Now those functions are very simple, right? Now what if we're given a function which is not this simple? What if we're given a difficult function like this one? The integral of 2 sine x cosine x. Now, if we only have a sine, or we only have cosine, this problem will be very easy, right? Now we have a product of sine and cosine. How should we do this one? Okay, no matter what is your idea, one thing you should never do is you should never write this as a product of two integrals. Now this is totally incorrect, because we don't have such a rule. No, we don't have such a rule. We have a sum and a difference rule, which means if we have an integral of a sum or difference of two functions, then in this case we can split this into two integrals. Now we can do this. But if we have an integral of a product, we can't just write this as an integral of one function and multiply by an integral of another function. No, we don't have such a property. Okay. So how can we do this problem? Now, the power rule cannot be used here, and the derivative formula for sine and cosine cannot be used here. So to do this problem, we're gonna develop a new method, a new technique, and that technique is called U substitution. So I know Okay, I know here, what I want to find is an antiderivative of this function. Let's say I call that as a capital Fx. The answer will be capital Fx, will be this function, such that when I take the derivative of capital Fx, the result will be 2 times sine x times cosine x. If I can find a function which satisfies this condition, that function will be my answer, right? Okay, so how can I know which function will satisfy this condition? Now, at this point, we don't know. But let me tell you what the answer is, okay? Let me tell you what the answer is. Okay, let a function capital X be sine x squared, or we can write as a sine squared x. Okay, so for this function, what is the derivative? Or how do you find the derivative? Okay, for this function, to find the derivative, we're gonna use chain rule. We're gonna find the out function and the inner function, right? Now the out function is x squared, and the inner function is sine x. That's why the composite function f of gx equals sine x squared. Okay. We know the out function. After we know the out function and the inner function, then the derivative, according to the chain rule, the derivative of capital F is equal to the derivative of the little f, the derivative of the out function with the inner function plug in, and multiply by the derivative of the inner function. Let's see what this is. Okay, the derivative of little f is 2x, and the derivative of gx is cosine x. Therefore, the f prime of gx, that is a 2 times cosine x. And the g prime of x, that is cosine x. F prime of gx, that is 2 sine x. And g prime of x, that's cosine x. Okay, now you see, since the derivative of a capital F equals 2 times sine x times cosine x, which is what we have inside the integral, so the function capital F is an antiderivative of this function. Therefore, because it's an antiderivative of the function 2 sine x cosine x, the integral, this indefinite integral, equals sine squared x plus c. You see what happened here? What will happen here is the function inside this integral is a result of a chain rule, right? It's the result when we apply the chain rule to this function. So we can get this. So if we summarize here, suppose I have a composite function which I write into f of gx. So here I let the f be the out function and the gx be the inner function. When I take the derivative of this function, the chain rule gives me this result, right? The result is f prime of gx times g prime of x. Now, if I take the integral of a function with this pattern, if I take the integral of function with this pattern, the result will be the antiderivative, which is f of gx. Okay, so now this is very clear, right? This is given by the chain rule, so the integral of this is f of gx. Now the question is, if like for this function, how I'm supposed to know which is a native f and which is a native g, right? Because of course, if I can know the native f is a x squared and the native g is a sine x, the answer will be sine square x, right? We can do that. But the problem is, how can I know just by looking at this? How can I know which one is a native f and which one is a native g? So to do this, we're gonna use the technique we will see in a second, the U substitution. So the idea is to do something like a change of variables. Okay, so let me explain in this way. Suppose we have an integral of f prime of x dx. Now, the result we can write as native fx plus c. Why? Because since when we take the derivative of native fx, the result is f prime of x. Then that means native f is an antiderivative of f prime x. Okay, that's why the integral of this symbol f prime x dx is fx plus c. Okay, once we understand this, we can do this one. So if I change the gx by using a letter, now this letter usually we use a u, so that's why the method is called U substitution. So if we change the gx into u, so f prime of gx, it becomes f prime of u. Now, what about the g prime x dx? What about this term? So if u is a gx, when I take the derivative of u, the du over dx, this will be g prime of x. Now this is like the writing of derivatives, right? Like if y equals fx, then the derivative of y we can write as a y prime, we can write as a f prime, or we can write as a dy dx. So dy dx, dy over dx equals f prime x. And because so like here is this is we have what we have right now is a u equals gx. That's why du over dx equals g prime of x. Okay. And since these two are equal, if I multiply a dx on both sides, the du will be equal to g prime x dx. So this term will be replaced by du. Now, this just like what I wrote here. The only difference is in this integral, the variable is x. Here, the variable is u. Because when the variable is x, the result is fx. Now, when the variable is u, the result is fu. Now, the advantage of doing this is we don't have to consider what is a gx. We don't need to find what is little g. We just need to find what is the antiderivative of this function little f prime. Okay. So idea is we will change an integral of a completed function into an integral of easy function. What function is an easy function? A function which we can use a power rule, or we can just use the sine or cosine to find the antiderivative. That function is what I call the easy function. Okay. Now let's look at this problem again. So if we let u be sine x, okay, and then so du over dx, I take the derivative of this function will be cosine x. Then if I multiply dx on both sides, I will have a du equals cosine x dx. Now you see I circled this, I marked these two terms because in the original integral, the function sine x is replaced by u, and the another term cosine x dx, these two terms together, they are replaced by du. And after I do this, I can rewrite the original integral and write it in terms of easy integral 2u du. Why this integral is an easy integral? Because we can solve this integral by using power rule. By just using power rule. So this equals 2 integral of u du. So this is just like a x dx, but here we write this in terms of u. Now, according to the power rule, the antiderivative of this function is a u to the power of 1 plus 1 over 1 plus 1, which is 2 times u squared over 2 plus c, which is u squared plus c. Okay. And the last thing is to bring the x back. Why? Because in the problem we're given, everything is returned into x. So our answer should also be returned into x. So how to bring the x back? Remember which term does u equal, okay? Or which term do we let u to replace? The u equals sine x. So u squared is sine x squared plus c. So that's how we solve for this problem. Okay. Now you may have question at this point. Why I let u be sine x? Why I don't let u be cosine x or sine x times cosine x? Actually here, I think if you let u be cosine x, that also works. but how do I know u is a sine x or cosine x? So this will involve a problem which we call it how to choose u. So usually we choose the quantities under a radical or raised to a power or at the denominator as u, just usually. So there is not like a formula, or there is not like a guideline tells you, okay, u is always be what, or u. So the best way to do this is to practice, because the more practice you have, you will be more experienced. Okay. In the next video, I will show you this example, and then I will show you if I choose like a wrong u. If I choose u to be something like a difficult, how do I know I should stop? Okay.